Okay, so let's start our lecture today. So, yeah, I think last time I was stopped at, um, yeah. So I should. Okay, so yeah, I think I estimated the first uh like the loop one, right? So yeah, last time I think I do like loop one. And then for loop one, I think most of the points that I evaluated, so over the 1 over the omega square, I think they lie in the right hand side of the plane. Okay. So now, so today I'm I'm trying to continue this analysis, right? So last time, so I computed only one case. So this is the loop of length one. Okay, so um, so now let's say any two case. Okay. So okay, so I think there are two rows, right? So one is that, so basically if you take over 1 over omega square, so first you take the which is equal to 1 over r square, 1 over, so e to the 1 over e to the 2 I theta, right? So basically you first so first you double the angle and then second you take the inverse. Okay, first you take the inverse, basically is the same thing as okay, so take the negation, okay, of the angle. Okay, so okay, okay, so here let me think. Wait, shoot, I think I was a little bit lost here. So yeah, let's draw it like that. Okay. In order for me to not missing miss point or something. Okay, so okay, so this omega 1, omega 2, and then with that, shoot. Let me draw this one. Okay. So this might be a misleading something. So here, and here, and also here. Okay. And then here, here, and here. Okay. So, and then let's label them. One. I think I started here last time. Okay. 1, 2, 3, 4, 5, 6, 7. Oops, I think I started miss. So this should be 7. Okay. 8, 9, 10, 11. Oh shoot. Okay. No. So it's not that. Okay. So, right. So I should go there. Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. So, okay, so here, this point stayed at here. Okay, I think I computed last time. Okay, so, and then this angle, at first I double it, and then I make it inverse, so it goes to here. Okay. And then this one, 3, I also do the same thing, right? So, I do a doubling here. Yeah, so I do a doubling here, and then I take the inverse. So, yeah, so roughly speaking, it's like here. Yeah, so it's like 3 here. And then, so for this 4, I do a doubling here, and then inverse. It's like here. And then 5. I think. Wait. So with 5, you do a negation. Yeah, you get the same thing, right? So you don't change anything. And then for the 6, so what you do is that, okay, so, yeah, I think you have to be a little bit careful here. So for this 4 here, right? So, okay, so let's do some computation here. So, let's say 4 is equal to some radius. Let's say r sub 4 e to the I theta. Okay. And then for the 6, so this is theta. So it's here, this is also theta, right? Okay. So, okay, maybe this is a little bit misleading. So I will say, maybe I call it P4. Okay. Yeah. So let's call this piece. Okay. Okay, so and then so this should be P1 stay here, and P2 goes to here, P3 goes to here, P4 goes to here, and then this is P5 goes to here. Okay. So so then you have a P6, okay, which is equal to also same radius as R4, right? So let's call it theta 4. Okay. So and then e to the I pi minus theta 4. Okay. So and then you have the 1 over P6 squared, which is equal to 1 over R4. Oh, okay. So I think for the radius, okay. Yeah. Definitely this one cannot be Yeah, so I think there's another issue about this modeling is that the radius may not be. Yeah, so I can only talk about the angle here. I can not talk about the radius here, right? Um, yes. So because the different points, they correspond, their radius is very different. So when taking the 1 over, actually they are very small here. They might be small here. So is there anything that I can do in order to compute these? Right. Oh, wait. Okay, so I think the idea might be that if we just care about the angle here, right? So if we just throw the radius away, like I think so basically I think you can somehow kind of split this whole axis into like 4 parts, right? So yeah, so I mean, like if you draw this diagonal like here, and then another like diagonal like here. So for the points that lies in the first, or actually, I think it was back. So I think 8 different parts. Okay. So let's look at the region 1. Okay. So if the point there lies in the region 1, so what happens? So if you double them, they must lies in the, yeah. So lies in this region. If you double that, wait, no. So if you double the angle, they lies in the first quadrant, right? So then you take the inverse, then they lies in the fourth quadrant. Okay. Okay. yeah, so okay, so points in this region 1, let me see, so do I, okay, let's call this a number what's the number? Capital P. Okay. So P denotes the operation of taking the 1 over like square operation. Okay. This is not the exactly the y plus P, but just the capital P. Okay. So so then by the transformation P, it goes into the fourth quadrant. Yeah, quadrant. And then similarly, if you have like let's say this is 8, okay. So points in 8, after you do a P transformation, P operation, then it becomes in the first quadrant, right? Okay, so and then if your point lies in the second number 2, right? If it's in number 2, then to a double angle. Then here and here, right? It's in the third quadrant. Okay. So third quadrant. And then number 3, you do doubling. So okay. So you double this one. Pi plus okay, so the angles are what? The angles are exactly between pi over 2 and 4 pi over 3, 3 pi over 4, okay. If you double it, yeah, so if you double it, so here, if you double this angle, it will be here. If you double this double this angle, you do a yeah, so you may get a region here, which also lies in the, I think it lies in the second quadrant. Okay. Because the least one, okay, get mapped to here, and then this one get mapped to here, right? Yeah, so therefore it must lies in the, sorry, and then you then you take the inverse, then it lies in the second quadrant, okay. And then let's say 4, if you take a doubling, then this side actually gets to map to here, and then okay, this side get maps to here. Okay, so then after a reflection, it goes back to the first quadrant. Okay. Okay, so oh, okay. So actually, let's delete this 8. Okay, let's make it like let's make it like symmetry. Okay, so here, let's take off it's 5 here. Okay, so for number 5 part. So where does it lie? So so here this bound. Okay, so after taking doubling, it becomes here, and then this guy doubling. So you get another. It becomes here, right? And then you take the inverse, lies in the fourth quadrant. And then 6. Yeah. So for 6, so here this one is here, okay, and then this one is here, and then you take the reflection, becomes third quadrant, okay. And then the 7 one, okay, so here, and so it's third and then second quadrant, okay. And 8, I think it's the first quadrant, okay, we just compute it, okay. So, okay, so, okay. Okay, so, I think the cancellation, yeah, so if we think of the way that cancellation works, would be exactly like, so if you think of the first quadrant and the third quadrant as a pair, right? So, yeah. Then you may think of, okay, so then you may look at okay, so I'm labeling, let's see, so the first quadrant, I will use the yellow color for the first quadrant, okay. So this eventually is 4, okay, so it maps in the first quadrant, okay. And then, so I'm using yellow color, okay. And then also which one is mapped in the first quadrant? 8, right? Okay. And also for the third quadrant, okay, for the third quadrant, let me use this dark blue for the third quadrant. Okay, so I have 2, and also I think it's 6, right? I'm guessing. Okay. Okay, so okay, so if you forget about radius, then I think that might be the pattern here. So Okay, so okay, so get back to our scenario, right? So if we get back to our scenario, so let's see. Mm, okay, so okay, I think that it has something to do with the ratio of this values, right? So because if this ratio, certainly this ratio is like longer, this is longer and this is shorter, right? So but somehow after that they get into the second quadrant, the second part. Okay. So maybe like still some points here, maybe some point here. Okay. So right. Okay, so what happened? Let me think. Yeah. So yeah. So why? So what is my question here? So um. Can we actually? Okay. Okay. So um. I think before we used a technique like remember like we show like an equal case, right? So I think I showed that this one. So I assume that this and they're equal to each other, right? So then I will have this situation, right? Wait.